After achieving a massive success as Chandrayaan 3 lands on the moon, India became the first country to make a soft landing on the moon's south pole. The Pragyan Rover has now started its probe on the moon. The rover named Pragyan was carried to the moon in the belly of the Vikram lander after the lander touched down. Panels on one side opened to deploy a ramp that allowed Pragyan to slide down to the lunar surface. Pragyan is now roaming around the moon, gathering data and images that will be sent back to Earth for analysis. It is carrying two scientific instruments that will help scientists to understand the composition of the lunar surface and the minerals that are present there. Pragyan is also communicating with the Vikram lander, which is now sending the information to the Chandrayaan 2 orbiter. The rover moving at a speed of 1 centimeter per second. With each step, it's leaving an imprint of the Indian Space Research Organization's logo and emblem on the lunar surface. In fact, let's tell you more about what all so far is coming in from the lander and its camera. So as you can see over here clearly that the Chandrayaan is, has landed on the moon, of course, is clearly deployed its Pragyan rover, and now information and images are coming in from the moon to us. So this was, of course, that moment when that touchdown happened. It happened at 6:04 p.m. on the 23rd of August 2023, and very soon after that, in fact at 8 p.m. itself, we got the first photo of the moon's south pole after landing. Remember, previously already we had got some sort of images already, but now a close image was received after landing on the moon's surface. And we also have now, through the lander horizontal velocity cameras images, accessed further shots of the moon, which can, of course, show you the craters and the color of the moon's surface, of course. These are other pictures that have emerged of the south pole of the moon. This is a portion of the Chandrayaan 3's landing site, which is an image that came in at 9 p.m. on the 23rd of August. This is a portion of where Chandrayaan 3 has landed. Remember, a point now that will be known as Shiv Shakti, as the Prime Minister said in his address at ISRO yesterday. This is the point when the rover came down on the ramp from the lander. It rolled out at 8:31 a.m. on the 24th of August 2023. Historical images, and now it's roaming around that Shiv Shakti point. It's roaming around multiple centimeters around the landing point, and it is, of course, sending us more and more images from the south pole of the moon. It's of course collecting more and more data which we are accessing. I will now be taking that across to our guests as well, who are joining us on the broadcast. Manish Purohit, ISRO scientist, is joining us live. We also have Group Captain V.N. Jha, former Joint Director DRDO, joining us live. Wing Commander S. Sudhakaran, former Indian Air Force officer, also joins us live. And Arjun Gulia, senior scientist, is also with us as well. Let me begin with you first, Group Captain Jha, on your take on what all so far we've managed to access already from the rover, from the images and the data being sent already by Chandrayaan 3.
Thank you very much, Uday, and entire nation compliments you, because you were the first to break this news that the rover has come out and the rover has taken a picture, and that we discussed at your channel in the middle of the night, just before middle of the night. So compliment to you for that particular breaking news. We must remember a few things. Look, Chandrayaan 3 has gone to a place which is different from where the earlier Americans, the USSR or the Chinese had landed. It is certainly a difficult place and a different place for various reasons that I'll not go into details of it. But please do remember, we do know, we know because the Americans had told us, the Russians had told us that in and around the place that they had landed their landers in those respective years, they told us that it is being impacted continuously with the meteorites, asteroids, comets, celestial body, mixed with some alien elements which were not of the moon's origin. And that is what the samples mostly they had collected. And in those samples, they had told us that in and around the surface, there are the molecular particles, the charged particles of neon, helium, hydrogen, argon, carbon dioxide, carbon monoxide, methane, trace vapors, all these they have told us that it is in and around the equator. They have also told us earlier that the major elements in the surface that they had analyzed contained about 43% of the oxygen, 20 odd percent of silicon, 19 or 20% of magnesium, iron, very small percentage, about 10% or so, calcium, aluminum, chromium, even titanium in a trace amount, 0.1 or 0.13%. So this is what Americans had told us there after they had landed. Now, we have landed at the South Pole, and the South Pole is a pole where the immediate impacts of those meteorites, asteroids, comets, or the celestial body are the least. So what we are likely to find in this place is something what our Chandrayaan 1 had seen, that was whether the water or water crystals or the ice was there. Secondly, least amount of impacts have been there on the South Pole or even the North Pole. So as a result, least amount of the contaminations we are likely to face, and what our rover is moving around on the surface is likely to be more of the moon's original constitution. So all those rocks, all those stones that a rover is going to analyze, whether by the alpha particle or the laser, it is going to tell us the story of what the moon is made of. That is the original moon surface, in most probability, what it is likely to be. And as you mentioned, rover has got two elements. One is the alpha particle analyzer, which will analyze those moon's soil. We call it regolith. It is going to analyze the regolith and send us the data, which all composition, what is the composition of the soil of the moon's surface. That data is going to come to us here at ISRO. And secondly, the laser spectroscope is going to look within the surface of those moon rocks, and then it is going to tell us that which all elements are in that rock. There are certainly few elements that I have told you that is already there. ISRO has got all those formulas within their network, logic network, that we will know which all elements are there. But I hope ISRO also keep the strings open, the ends open, so that should there be any 109th, 110th element of the periodic table which has not been found anywhere till now, can those also be found? So we don't know right now, but those are the possibilities. So having talked onto this, there are many other things also. Water molecules could be there, the ice could be there. Water molecules of the ice on the surface is going to be the least interesting, because that would have been contaminated with so much of radiations that cannot be used for any constructive purposes. But yes, that can be broken down, hydrolyzed to have oxygen, to have hydrogen for fuel purposes. But there is a long process to use that as a fuel. So those are the variables, those are the possibilities, and it is only the opening of the window that we have opened in the South Pole. Chandrayaan 3 has opened that window. More are to open. Surprises will be there. Secrets of the moon's surface will be there. Secret of the cosmos will be revealed by the moon's Chandrayaan 3. So let's keep our breath at a hold, and let's understand what all this Chandrayaan is going to tell us today.
All right, Group Captain Jha, stay with us. We're getting breaking updates coming in on the program. ISRO has tweeted a latest update on Chandrayaan 3. Chandrayaan 3 mission updates coming in. Here are the first observations from the chast payload on board the Vikram lander. Chast, that is Chandrayaan surface thermophysical experiment, measures the temperature profile of the lunar topsoil around the pole to understand the thermal behavior of the moon's surface. It has a temperature probe equipped with a controlled penetration mechanism capable of reaching a depth of 10 centimeters beneath the surface. The probe is fitted with 10 individual temperature sensors. The presented graph illustrates the temperature variations of the lunar surface near depth at various depths as recorded during the probe's penetration. This is the first such profile for the lunar South Pole. Detailed observations are underway. The payload is developed by a team led by the Space Physics Laboratory, VSCSC, and in collaboration with PRL Ahmedabad as well. So already latest observations, more latest observations coming in. We're getting an understanding of the South Pole temperature of the moon, Group Captain Jha.
Absolutely. Look, the lander has got four equipment. One is that it has got the chest, what you have mentioned. It is going to make the thermal mapping of the surface on the South Pole. In and around the equator, US has told us much earlier, decades earlier, that the temperature in the daytime goes to plus 125 plus, in the range of 125 plus, and in the night time it goes to about minus 235. That we know on the equator, in and around equator. But what happens on the South Pole? There, the temperature may not rise to that type of, because the sun ray is coming at a slant. There is no atmosphere, of course. So, Chandrayaan 3, that chase, is going to give us a thermal mapping, which is absolutely original. It might not be known to the others. It could be entirely different type of map that others had imagined earlier. ISRO will getting for the first time. Other than this, the Rambha LP language probe that is there, that is going to tell us what are those wandering molecules, ionized plasma molecules, which is wandering around the surface. That will tell us the story. And ILSA will also tell you the story that what type of seismic activity is going on there on the South Pole. It may not be the seismic activity of the moonquake. It may not be all those earlier in the past that the balls had been there on the surface. It may not be those, but any impact that happens or any rumbling that happens underneath, so that would be known by the ILSA, that is the seismic activity going down. And one more important, the last thing, is that it has got a laser reflectometer. And that laser reflectometer will tell us exactly how much is the distance from the moon's surface of Earth. And everyone has been telling us that moon is going away from us by 1 inch every year. Is that 1 inch really the correct? Is it the real figure to be trusted? That reflectometer, laser reflectometer, will tell us the story over a long time as compared to the Earth's distance as well as the other celestial body. So these are the equipment with the lander. And last but not the least, even that propulsion module, what is right now orbiting around the moon, that also has got an equipment which will make the thermal mapping in the NIR section, near infrared section, to give us how the Earth's atmosphere has got the heat mapping, whether it is really that climate changes, what is happening in the upper atmosphere, whether it is that the heat trapping going to be there with those molecules which can cause that greenhouse effect. So those stories also will be told for the Earth, as well as it may also look in the coming years the distant solar system, distant stellar system, because there is any other inhabitable planet in the cosmos anywhere beneath.
Let me also take that to Manish Purohit. Manish Purohit, already we are, of course, getting information coming in, and this is perhaps the first such chase reading and an in-depth temperature analysis of the South Pole of the moon ever. So, clearly history continues from Team ISRO.
See, actually, studying the South Pole or South Polar region is important because we can say that getting depths of what is stored there in the form of information that we can have our hands on. Just if you look at that graph, you can put that graph on the screen, and for the viewers to watch, you can see that within a difference of just 10 centimeters, the lunar regolith is experiencing a temperature difference of around 60 to 70 degrees centigrade. You can see that top layer is reading somewhere around 60, while at the depth of around 8 to 9 centimeters, it is going to minus 10. Now you just think about it, at a difference of just 10 centimeters, it's a big thing. It's 70 degree difference in the temperature is something big. So what actually happens there? That's why we have to study it, because moon can be referred as archive, a museum of our history. The history which will give us the information that how Earth was formed. See, actually, if you go back and look at the beginning, when we were a big gas nebula, when it was like, the solar system was deciding that what all it has to make, and what are the different planets it will be there, how the sun has to be. information of from that particular point till the point we have reached here over these few billion years, we have to understand that part, and for that we needed something very pristine, and right now our lander and rover are in that particular region which we can call it's very pristine for us to understand what exactly the geological history of moon is, because geological history of moon will directly lead us to the geological history of earth. So what are the experiments we are doing? They all have big scientific applications. If we talk about ILSA, so NASA has done elaborate studies about lunar quakes. Elaborate. In Apollo missions, they have flown many seismometers, but all of them were in and around the equatorial part. We are the first one to put a seismometer in the south polar region, and that too it is highly sensitive. It is so sensitive that even a meteorite striking the surface of the moon will get itself registered, even it is on the other side. So it's very, very sensitive. Now, regarding the moon quakes, moon is supposed to be 1,000 times much quieter than Earth because we have tectonic movements. But there is a speculation that lunar quakes may not be because of the movement of the plates. It may be something else. It may be some tidal effect. So we have to get more details about it, because that's our next place where we are going to put our astronauts, we are going to put our base camp there, because we are planning to use moon for our next jump into the interplanetary exploration. So this is important. And if you have to understand a locality and a local environment of some place where we have to put our experimental setup, our base camp, we are planning that, okay, there will be more frequent visits and tours to that particular location. So we have to understand how the high energy particles coming from the sun, because we have atmosphere, our atmosphere protects us from all those high energy particles and high energy radiations, but there is nothing on the moon to protect it from. So how the plasma thing happens, what is the dynamics of it, how it varies over the duration of those 14 days when sun is shining, and when there is no sun, what happens to those things. So we have to understand these are the fine little details that we have to understand, because the aim is that place will be kind of inhabited by human in the coming future. So we have to understand every fine print of it. Regarding the meteorites and the lunar sample for the water and all, see, meteorites are the main basic source of water, not only on moon, but most of it on Earth. Most of it, maybe 99% of it is from the meteorites. We didn't have water. We got all our water from the meteorites. So meteorites are the biggest source of water and organic material, how the life started on Earth. So we can say that our life, the life on Earth started with those basic components which were delivered to us through these meteorites or asteroids that were striking the Earth. So if we get our hold on those places where we know that meteorites have struck moon and really hard and they have delivered water there might be a possibility, because if those areas are permanently shadowed and there has been no interference of any high energy radiation or high energy particles from the sun or any other place, so we may get some surprises also. So, and if you look at the southern polar region, so southern polar region is very heavily disturbed by these meteorites. The count runs in lakhs. There's large number of them, and exactly at the southern pole, the crater, because of those impacts, is around 12 kilometers deep. So that's why the whole focus, everything completely, totally, all the resources have been concentrated on exploration of that part. Now a question may be, why not the northern polar region? Why not? Why only southern polar? Because northern pole is not that much affected by all these impacts. Crater count is less. It is relatively smoother surface if we compare to the southern polar region of the moon. That's why even NASA, ESA, Japan Space, Roscosmos, ISRO, China, everyone wants to go to the southern polar region, and we are the first one who are conducting the experiments and getting some good insights.
No doubt. Wing Commander Sudhakaran, let me quickly draw you in here now. There's a lot more that, of course, will be gathered in the days ahead, but it's been barely 72 hours, and already the kind of information coming in, the pictures, the imagery. What is your take on that, Wing Commander Sudhakaran?
I am really not a selfie kind of a person. So, the selfies that the Pragyan and the Vikram landers are taking, good luck, and let's cherish those. So keeping that aside, the idea is not to take selfies. The idea is not to say that I landed there. It's a far more bigger game that we are going to get involved in. And the idea of this mission is to look for rare earth minerals. and rare earth minerals, which are going to be applied in future electronics, future defense technologies, green energy, medical, building of future far more efficient batteries, glass, ceramics, and so on and so forth. Okay, so what are these, general rare earth minerals that we are talking about? If we actually look at that, we're talking about plagioclase, we're talking about pyroxenes, we talk about olivine, we're talking about ferrite, we're talking about tanzanites, and these are the kind of few rare earth minerals apart from helium-3, which is considered to be a very, very clean fuel for the future fusion reactors. Now, if future fusion reactors have to be smaller, which will actually enable interstellar planetary missions, which will give us perennial source of energy from within. It's exactly the process that happens inside the sun. So if we can replicate that and make these reactors smaller, and that's where the game is. And to make all these things, we need not only the rare earth minerals, we also need helium-3. So the Pragyan rover, in its initial phase, is looking for evidences of the lunar regolith. The lunar regolith, which is a fine dust particle, which is thought to have abundance of helium-3, though in a far more diluted condition. We are going to explore there. And countries, we can't rest on America to tell you what it fetched from the lunar mission, because they're only going to say what it suits them. You need to dirty your hands on the lunar surface, find it out for yourself, what is available, how it can be used, and that's how you are going to fuel and feed the next generation of technologies that are going to take birth from the womb of the Indian intellectual's mind. That's the game that Pragyan is involved in. And it's far too early to say where it has reached, how much it has reached, but I'm pretty sure the ISRO scientists are in this same game, and they're equipped with enough sensors to collect enough samples out of it. So we will have to follow this mission with a series of missions. Almost, if I would have my say, I would want a mission every quarter, because we know how to land there. Now it's about replicating this landing every quarter. Let's cheer that landing every quarter. Bring in tons of samples from there. Find out a cheap method to extract and mine there. That's where robotics is going to play a big part. It's not the humans who are going to colonize moons. It's the robots that you're going to conceive from here, who are going to be there, because you don't need oxygen for them. You don't need to set up hospitals for them. You don't need to set up entertainment systems for them. They will work relentlessly. So that's the revolution that India needs to usher in, and bring these bots onto the lunar surface, look at mining at a scale, get these products that are required, which will revolutionize it. When people talk about, how does it matter to a common man? It does matter, because you are going to get sophisticated medical treatments out of that. You are going to get sophisticated batteries out of that, which will charge your mobile phones. It will charge your everything in your home. You will lead a far more energy efficient life. You will destroy the environment less. The rare earth minerals, please understand, when you do mining in the earth, you devastate the environment here. But moon, there's nothing of that sort that happens. So you're going to get everything clean. That's the game that Vikram lander and Pragyan are in, and that's probably what ISRO has sent this mission for, the best of my ability, because I have no insight into what ISRO's design plans are. But if that were the design plans, we need to get this going in scale. And that's what is going to usher in a new era of competition between even the United States, the Russia, and the Chinese. Because they're not going to allow you to do that mining, because then it becomes like you're going to draw boundaries there. Who's going to own what? How is it going to be decided? And please understand, if China is going to set up a base by 2027 there, you can't believe that country. It doesn't leave a piece of land wherein a blade of grass doesn't grow on Earth. And for a piece of land that is there in the moon, which is so infested with rare earth materials, which is so expensive to get, which is so important for our technology growth on Earth, they're not going to let you be so free. So that's why we cannot rest. I've been continuously stressing for the last week or so. We cannot rest on the laurels of what Chandrayaan 3 has accomplished. We need to build on them. We need to get more hungry. It's like Ravi Shastri telling on TV, telling that if you have 100, take a fresh guard. Go for 200, go for 300, and that's what India needs to do today. And we need to mine these rare earth materials, and then bring in new technologies. The robotics, the 3D printing technologies, which are actually going to set up new systems there on an alien planet. That's what I see the future as, and that's where India needs to put its money on.
Right. Is that something you agree with, Arjun? Because at the end of the day, of course, there is very, very limited information, of course, that has already come in. But as I said, it's been barely 72 hours. So this is great information, and pictures and data and temperature readings already showing us about, as the saying goes, कि ये तो trailer है, अभी पूरी picture बाकी है. It's just giving us a glimpse of what all is to come, Arjun. Gulia.
Yeah, it is. Because the thing is, please be sure of one thing, that ISRO may not release all the information if they think that it is sensitive to the national strategy, like Sudhakaran said, right? Because in the South Pole region is pretty different from the equatorial region where NASA have already went. Because NASA, if they went there, they've already basically the plethora of moon rocks already in the laboratory. They have already known what is the part of that regolith. But the South Pole is completely different from that, because the South Pole does not receive sunlight at all. So it is very much well placed to preserve the knowledge of the earlier part of the solar system, as well as the water, which is the main reason why we are going to the South Pole. So what all we have gotten so far, it is only the trailer, because the reading from the spectrometers from the Pragyan rover, they are not out now. We don't know what all elements are there. We don't know what is the mineral composition of there. That is something that Pragyan rover is going to tell us. Similarly, the Vikram lander also have certain equipments on it, like the seismograph. It will also basically, like Manish said, the reason why moonquakes happen, it is very much different from what is there on Earth, right? Because moon's core is not as molten as Earth's core. If there is a meteor striking on the backside of the moon, the vibrations do travel to the front side, right? And that is the reason that what is the intensity of those moonquakes, how frequent they happen, these kind of information is going to help us while designing the station on the moon, which is going to be there in NASA's Artemis mission, and India is also part of the Artemis Accords. So a lot of information that is going to come from this Chandrayaan 3 mission is going to shape the future missions of the moon, not only from India, but from all over the world.
For more such videos, subscribe to the NewsX YouTube channel, hit the bell icon.